Hello everyone, I'm Masaru Kase from Fujitsu. I worked for Supercomputer Fugaku development, mainly hardware system design. I talk about Supercomputer Fugaku and how to develop, and introduce our commercial supercomputer. Let's get started. The Fugaku has been developed to contribute to the solution of various problems facing modern society and important issues in the field of science and technology. Expects use in a wide range of fields such as big data and AI. These are Fugaku's design targets and our approaches. First is application performance. We set our performance goal to application performance 100 times faster than that of the K computer. Our CoDesign approach of working with application development teams was effective. Second is power efficiency. We set the maximum power consumption of system to 30 to 40 megawatts. To achieve superior power efficiency using a general-purpose CPU, we used cutting-edge silicon technology and our proven low power and high performance design. We also implemented power control knobs to reduce power consumption. Usability. We supported the ARM ISA and ARM standard Linux distributions. These are key to broadening applications and offering same usability users are accustomed to that the Linux environment provides. K computer is also developed by Riken and Fujitsu. K computer is ranked number 1 in top 500 in 2011, and it also won first prize in HPCD and Graph 500. It has been competitive in various fields and used for many users for over 7 years. We provided PRIMEHPC FX10 and FX1000 by developing and employing new technologies while K computer was providing computing power. Fugaku is developed by Riken and Fujitsu successfully based on our experience and challenges. Fugaku's shared or public use started in this March. PRIMEHPC FX1000 and FX700 using Fugaku technology are available. This is the preparation stage and Fugaku development schedule started in 2014. The target applications of Fugaku were selected in 2012. Then a feasibility study examined the architecture and performance. From the beginning of development, CoDesign with application development teams assisted estimating the performance and tuning the software and hardware, and general use of Fugaku began from March 2021. Our goal is to obtain optimal performance 100 times the application performance of the K computer with a 30 to 40 megawatts power budget. Application developers are also optimizing their application, not limited to optimization of compilers, libraries, and hardware. In our CoDesign, application performance is estimated through a combination of the computation, communication, and I/O time. For computation time, 2 levels of performance estimation were used, brief and precise. Communication time was estimated based on bandwidth, latency, and attribute of the communication patterns of applications. I/O time was also estimated separately, based on the volume of I/O data. Then, we optimized applications, compilers, and resolve bottlenecks. For brief performance estimation, execution information of applications sampled by performance counters of our PRIMEHPC FX1000 were used. We replaced performance count of FX1000 with parameters of Fugaku, such as commit cycle instruction numbers, barrier wait cycles, instruction fetching, branching, floating point execution, and L1D, L2 data load and store wait cycles. For precise estimation of primary kernels for applications, our cycle-based simulator was used. Around 2015, two levels of CoDesign loops were applied for each application kernels to define the architecture of Fugaku. The longer turnaround time loops include the modification of architecture parameters. We define and refine a set of architecture parameters, evaluated performance, identified hardware bottlenecks, and explored the design space. Examples of architecture parameters are frequency, number of registers, SIMDBs, cache structure and size, number of cores, memory, interconnect parameters, implementation of instructions, that is, combined gather. The shorter turnaround time or inner loop only implement and tune the kernel under certain architecture parameters. This loop searches for suitable application implementations. As I said, that Fugaku is targeted to achieve 100 times higher application performance than that of the CoDesign. CoDesign team select 9 target applications from priority issues. This table summarizes that the result of the target application performance in 9 target applications. Fugaku performed 100 times application performance of CoDesign for Genesis and Nikon plus LTKF. We developed the A64FX CPU, which supports the latest ARM ISA with scalable vector extension effectively. The CPU achieves superior peak performance in both calculation and bandwidth. The A64FX, developed by us, is world's first CPU to implement a scalable vector extension, an extension of ARM v8.2a instruction set architecture for supercomputers. Manufactured using the state-of-the-art 7nm process, it can provide a theoretical peak double precision floating point performance of 3.3 teraflops. Furthermore, it's capable of high throughput single precision and half precision floating point computation and 8-bit, 16-bit integer operation using its 512-bit wide SIMD units. This calculation performance shines in processing applications such as AI. Each node consists of one processor and uses HBM2, a world first for general-purpose CPU. Each node has a tremendous 1024 GB per second of memory bandwidth. And we integrate TOFU interconnect decontroller, which is used to connect nodes. It has the same 60 mesh torus architecture as previous CoDesign, but increased injection bandwidth. It also performs very good efficiency, over 9% of DGEM and 80% of stream triad. This is a physical image of the A64FX. A64FX is 60mm by 60mm package and integrates 4 HBM2. CPU chip has 48 cores for higher calculation performance, assistant cores for operating system tasks. You may see 4 core groups in the chip. We call this structure core memory group CMG. This is useful to connect memory very tightly and helpful for programming. Integration of TOF-D for efficient connection between CPUs. This figure shows how high bandwidth is implemented through the A64FX CPU chip from memory to calculation units. The table shows bandwidth at each level and byte per flow. Bandwidth is utilized effectively using out-of-order execution for data access. Last year, Supercomputer Fugaku was ranked number 1 in these 4 major supercomputer rankings. Fugaku is the first supercomputer in the history ranked number 1 in Top 500, HPCD, Graph 500, and HPLAI at the same time. The performance of benchmarks are almost 3 to 5 times higher than second-place machines. This is summary of supercomputer rankings. Red letters refer number 1 record at ISC20, November 2020, and green letters refer in ISC21, June 2020. These rankings evaluate a particular performance aspect of supercomputers. The ranks vary in benchmarks. Results support that supercomputer Fugaku can be utilized in many fields effectively, and our design approach targeting the application performance has succeeded. We think the CoDesign approach is worked very well. We had also won first place in the Green 500, which evaluates the power efficiency of supercomputers based on power consumption when measuring impact performance. Shown in figure on the left, we set up the AH64FX prototype, a 2-rack system, in the laboratory of our Numazu plant and installed 768 nodes. Was ranked number 1 in the world in the Green 500 rankings on November 2019. We are offering commercial products based on the Fugaku technology. PRIMEHPC FX1000 is the same hardware as the Fugaku, and capable of support the same software stack, offering the best application performance, energy efficiency, and scalability. PRIMEHPC FX700 is for easier installation and ease of use utilizing standard technologies like InfiniBand interconnect and open software stack. All these products use our ARM-based A64FX and support binary compatibility. These are commercial applications on PRIMEHPC FX1000 and FX700. We have been working with vendors to make their commercial applications available for PRIMEHPC. This table shows availability of commercial applications. Several applications were already verified on Fugaku. Open source applications are easily run on PRIMEHPC FX1000 and FX700 because we can use standard Linux distributions by ARM ecosystems effort. This chart shows computation speed compared with x86 server. Computation speed of FX1000 and FX700 is faster than x86 server, up to 2.3 times with these OSS. If you're interested in commercial applications and open source software on PRIMEHPC FX1000 and FX700, we prepared the materials on our virtual booth on this ISC21. Please visit our booth. Supercomputer Fugaku has been developed using a CoDesign approach with application developers and researchers. Its well-balanced performance that is optimized for application execution contributes to good performance in various benchmarks. The prototype Fugaku, known as the A64FX prototype, was ranked number 1 in Green 500 in November 2019. Supercomputer Fugaku became the first supercomputer in the history to receive the number 1 prize in Top 500, HPCD, Graph 500 and HPAI at the same time in 2020. Fugaku started shared use from this March, and many users are utilizing the computational power of Fugaku now. Fujitsu now providing PRIMEHPC FX1000 and FX700 based on Fugaku technology. We are working to expand ARM HPC ecosystem with many partners. Fugaku is the first top-end machine of ARM HPC system. We are continuing to develop high-performance machines to boldly go where no one has calculated done before. Thank you.